All right. Huh. Sorry about that. For some reason, YouTube dropped this morning. Um, so it looks like we're good. Um, yeah. So I'm getting stuff in YouTube also. Hey Ole, welcome to the stream, man. I don't know why it dropped this morning. Um, but it did. And I just restarted. Unfortunately, the downside to that is there were 11 people watching and we lost them. But I wanted to make sure that we were streaming on everything. Just checking that out right now. Yeah, it looks like we're good across the board. Hey, Michael, welcome to the stream, man. Things are looking good. This morning, I should have kept an eye on things, but this morning we updated a bunch of. Well, we went to the actual version 21 release of Angular. There's the blog announcement. And I was just looking through some stuff here, just to see in the release notes, what are the breaking changes. They added some nice stuff to the test bed. One of my favorites is that we've gone from an any or an any array, right, to a stronger typed array. I love that. It looks like we're getting some stronger type checks, which we've gotten caught up in already. But I'm not turning these to. You can turn them off by setting it false. I actually like them. I like my code to be strongly typed. So the other thing they did is they fixed up the bootstrapper, and there's a schematic to do this, but they also made it so that when you're running in a server environment, get platform and destroy platform will be no op, which is really cool. I see there's a new feature with entity resource in the NGRX toolkit. We're gonna have to take a look at that, Ole. That's actually really cool. Have to take a look at that one for sure. Using a combination of provide zone without zone.js won't cause problems. Now anything less than type TS 5.9 isn't supported. One of the things we did before the stream, I use Volta, and so we checked our versions and everything, and we're up to date to where we need to be. Oh, somebody was heavy on with entity, realized with resource wasn't getting. That's really cool. So yeah, that's really cool that we've got a resource entity. And able to pass in multiple signals into. Oh, that sounds cool, Michael. Being able to pass multiple signals into RX signal methods. That will be nice. So ignore changes outside a zone, blah, blah, blah. Angular no longer provides a change detection scheduler. Yeah, it uses the same scheduler now. Module ID was removed from component metadata. Interpolation option on components has been removed. Only the default is now supported. This is cool. And I think it's probably one of the least used features before they removed it. But in the past, you could set what symbols were used for interpolation. Now they're just going to use the default of the curly braces. I don't know of anybody who changed that, but that's a pretty significant breaking changes. Oh, so you pass in a factory and it'll watch all the signals on that, or not a factory, but an object. Well, that is a factory that returns an object with your signals. This is Angular elements, fixed signal input getter. So forms, the new directive will conflict with existing form array directives or form array inputs on the same element. Platform browser. Application config. Yeah, you're supposed to use the application builder now. So it makes sense that they would remove the platform browser. Oh, that's cool. Last successful navigation is now a signal. That'll be helpful. That means we can use them in computed and effects. Routed navigations take several additional micro tasks to complete. Tests have found to often be highly dependent on the exact timing of navigation completions with respect to the microtask queue. The most common fix for tests is to ensure all navigations have been completed before making assertions. On rare occasions, this can also affect production applications. This can be caused by multiple subscriptions to router state throughout the application, both of which trigger navigations that happen to not conflict with the previous timing. Interesting. Hi, Zoe. Thank you. My daughter just closed my door. So router navigations have some additional micro tasks to them, which if you're relying on the timing of that, what if I wanted to use 100 as if you're using 100 as your interpolation symbols, you deserve to be broken. That's all I got to say on that one. So interesting. I have worked in applications that rely heavily on router timing, and often add, sleeps for milliseconds because of the router timing. What they're saying here is that if you need to rely on the router, you should probably either be listening to, success signals instead of trying to time it, or basically this whole sentence or this whole paragraph is saying, don't rely on the timing of the router. They could add additional micro tasks or who knows what. The queue isn't guaranteed to be emptied in the timing that you think it will be. So there's a bunch there. Upgrade adapter. Oh, that's interesting. I haven't had to make an AngularJS application work in Angular in a long time. The last time I did use upgrade adapter, but now upgrade static, IE and non-Chromium Edge are not supported. That's fine. And then HTTP response status text is deprecated. Other than that, I wanted to take a look in here. If there was anything, add migration. I'm looking for the forms, and there may not be. So debalance for signals, form array. What I wanted to do is just see if there was anything in here that looked like they may have put back the pass-through that we ran into last time. And just make sure that all went okay. But it doesn't look like it, so we'll run some tests this morning. So the V21 release event. Great. We're launching experimental signal forms. Yep. Angular Aria has been launched. Your AI agent can use Angular's MCP server. I would like to do a stream where we just spin up a bunch of MCP agents and see what Angular can build for us. I think that one might be fun. New Angular applications are not including Zone.js by default anymore. That's cool. Experimental signal forms are here. So Angular ARIA was mentioned. The MCP stuff. VTest is a new default. Yep. Zoneless documentation and so much more. All right. No surprises there. When we ran our test this morning, nothing really changed, and so I'm not expecting things to change. But let's run a test, right? I got to update WebStorm. That's one thing I didn't check for this morning. The signal form docs are live, and maybe the custom controls one is live, or at least the PR more hashed out. Maybe, and that's one of the things we can take a look at while we update WebStorm. Is we can go here and let's take a look at signal forms. Forms with signals. So signal forms are experimental. There's our form to create a field tree, bind with the field directives, read field values, with set, basic usage, great validation, awesome. Next steps. Creating and managing data, form data with signals, field state manipulation, and validation. Let's take a look at form models here. So form models, yep. Creating models, great. Initializing all fields, dynamic field addition. Add a password field. Interesting. That's fascinating. I mean, it makes sense that you could mutate the form like this. I just hadn't thought to do it. But it would give you the ability to add stuff to the form. Reading model values. Reading from field state. Updating form models programmatically. So yeah, you can set the model itself, which was, I was trying to be silly about it last time. Update one or more fields with update, that's fine. Update a single field with sets. Loading data from an API. Common pattern involves fetching data and populating the model. Yep. And yeah, you're just updating the user model. Signal and everything else works that way. Two-way binding relies on field. The field directive. And the field directive updates the UI. So from the input to the model and then updating the UI. Model structure patterns, flat versus nested. Man, there's a lot here, a lot more here than we were originally looking at. Working with arrays. Array items containing objects automatically receive tracking identities, which helps maintain field state even when items change position in the array. This ensures validation state and user interactions persist correctly when arrays are reordered. Oh. So Angular is going to give your items a tracking ID from an array. That's fascinating. Initialize all fields. Keep models focused. Consider validation requirements. Plan for initial state. Okay. Custom controls. This is the one we were looking for. So creating a basic custom control. So this one, we've got a basic input. Great. We've got a template. This one's implementing form value control. So it's got a value on it, which means it can use the field binding. Minimal checkbox control. Again, form checkbox control, which means that we have to have it checked. So we expect that using your custom control. So this is the field binding for the basic input and the toggle. Great. Understanding the field directive works identically for custom controls and built-in inputs. Signal form treats them the same. Validation runs, state updates, and data binding works automatically. Note the schema callback parameter. Oh, schema path, yeah. Yeah, that's fine. Control interfaces, form value control. So that's interesting. Form value control must not have a check property. You have to have a value signal, a model signal. Form checkbox control cannot have a value property, and you must have it checked. Extend form UI control. So this is awesome that they're spelling this out. Disabled, all that's there. Validation constraints are all there. Field metadata. The adding state signal section below shows how to implement these properties in your control. How the field directive detects which interface your control implements and automatically binds the appropriate signals. So the field is looking for you to either have used the checkbox or the field control. That may be why we can't use field on custom controls, that we pass it through. Adding state signal. The minimal controls shown above work, but they don't respond to form state. You can add optional input signals to make your controls react to disabled state. Right. And so, yeah, you just add them to your inputs. And then when you bind to the field, you're automatically going to get disabled and all of that stuff that you want. Signal types for state properties. Most state properties use input, read only from the form, use model, value transformation. Yeah, date picker stuff. We'll come back to this when we build our date picker. invalid and errors. Form models guide. I think that's going to take us back. So we don't have something on passing the field directive in, which makes me think it's not supported. And the reason I think that comes down to this section on how the field directive, where the field directive detects which interface your control implements. That tells me that if we're not implementing one of those interfaces, then the field directive can't detect it and it stops working. That's my guess. So let's go pull open WebStorm. And hey, Gemini. All right, I think, so if we take a look at like the star input, for example. So with the star, oh no, we do form value control here. Is it inputs? Yeah, this is where we changed it. So let's rename this back to field. Field. So that picked up field. All of the other stuff stays the same. We'll save that, and then we'll go to the to-do form. And we should have something here that's not working anymore. App input. So yeah, we've got our field equals form.description. So it did appropriately rename it. That's really cool. That WebStorm is already up to date on this stuff. So let's go take a look. Yeah. So the required input field from the component input must be specified. On line 66. It's right there. There's my field. Wait, is this just the rename stuff happening? Let's go ahead and serve this again and just maybe I need to save this and save this and just make sure. So while that's rebuilding, hey, they may have fixed it. It looks like it may be fixed. So if we pop this open and bring up our, let's go ahead and clear our console and let's refresh. So everything looks good here. When we bring this up, this looks good. We're getting that. And we're getting that. It looks like they've changed it back. So the stuff we were doing with field tree is no longer necessary. Let's go ahead and look for field tree some more. Field tree. So the only place we were using it is on our input. Our input can now use field again, so that pass-through works again. So what we had to do before was a bug, and we've been able to confirm that we can go back to passing in the field tree as a required input. we can strongly type it, and we can use the field as the input name. Notice here we're not using, like here on the star input, we're using the form value control. On our input, we're not using any of that. We're just passing the field straight in, which allows us to bind to that field. And then in the to-do form, we're passing that field across. So I think you were correct, Michael. This has always been intended to be a pass-through. And just the last RC broke it, probably with the stronger typing. And with a little bit more testing before the release, they were able to fix it. Which, man, I was struggling to decide if I liked it or not. I'm glad it's back to the way it was before. This gives us a consistent. So when we create these, we don't have to have that extra cognitive overhead of, oh, do I use field tree here? Do I use field? We can just use however we want, pass it how we want it to look. And this is going to come across. So I've got a label and a placeholder here, and a label and a placeholder here. These are both set to models. They should probably be inputs, because I'm not planning on changing them. And so the other thing we can do here is these can all be read-only. And the only reason I want these to be read-only, it's not actually going to force these to be read-only, so we can still change values. But what this gives us is the ability to prevent people in TypeScript from changing these. So, you can't come down here and have some, well, you couldn't do it there, but you couldn't have some function, and in some function, we can't say this dot field equals, field for whatever reason, right? This doesn't work because field is read-only. So the way this works is this stuff gets all added to a constructor. This is all syntactical sugar for a constructor. And so this stuff all gets added to the constructor. So it's all set up at the time the class is constructed. So field still works. And we can go validate that by clicking here. And we can see this input still works. We're still getting the errors. Everything's still bound. So this all works. Yeah, that all works. So we're all in a good state here. I actually really like that. Thanks for pointing out the signal form stocks, Michael. They didn't go into our specific use case, but we were able to test it out anyway, and things are going well. So one of the last things we wanted to do was set up. We wanted to set up the save button also. So we can close to do input, star input, and close that one. We're going to leave the rest open for now because we'll probably need them. So we've got our store that has a bunch of immutable state in it, has a bunch of computeds in it. And we've got, select and deselect. What I do want to do is currently our buttons are not good. What would be a good thing to do here is if we take a look at like our it's our input, that's a checkbox. So if we look at our grid calls, we've got 1, 2, 3, 4, 5, 6. So what we want to do is make our buttons span the grid properly. So we're going to go class equals. We're going to do a call span of 6. And the other thing we're going to do, yeah, we could make our buttons justified to the end. And what this is going to do is now when we edit, our cancel button shows up at the end. And we probably need to make it a 7. Let's inspect this. Where is my grid? So we take a look at this grid. No, it's just that this is outside of the grid. That's fine. But that allows our cancel button to be full size and get the proper sizing and all of that. So I'm good with that. Let's go commit some of this stuff before we dig into the save button. So here, we're now able to use the field again, right? That's the only change we made here. Yep. So there we go. We'll push that. There we go. Okay. So at this point, we're ready for our save button. Let's also give just like we'll do a gap of 4 between our buttons just to give our buttons a nice gap. I'm gonna copy this. We're gonna go button dash success. That's a save. I'm gonna add a save function to it. There we go. And down here we can protected, save, boom. And for right now, we're just gonna console.log saving. And this dot selected to do. So there we go. So now if we go back to our console and let's edit this one. So we've got our cancel, we've got our save. It's fascinating to me that it looks slightly bigger, but whatever. You know what? I don't want the save button if because we can't edit anything if it's not checked. Well, that's not true because somebody Somebody may check it. So the save button should work. So there we go. Like we can test that. Boom. Set our stars. And if we save that, we should see it's still ID 3, description, that random number. Okay, so we've got an issue here in that the form isn't changing what's in the so the selected to do is not being passed to the form, which makes total sense. So what we really want is the model. So let's go back to that. And now if we edit this and we uncheck that, we give it a random number, give it a rating, and save. So we can see our task importance is a 1. I guess this is the task importance, not a rating. Our random number is 220, and we can see that we went from true to false. The interesting thing about this, and this is something that's really powerful about this form, is that this object is decoupled. This object is decoupled from the underlying selected to do. The really cool thing about this is if you wanted to implement, say for example, this task list was shared, and you could have multiple people editing it at once. What happens is we can get into this state where, say I'm editing over here, and Michael's editing over here, and Ola is editing over here, and then we go to save, right? Let's make these all go to the save button. Boom. Right, so we all hit save. Let's say that my edit is only the task name. Let's say that Ole's edit is the priority, and let's say that Michael's edit is this value. Well, in a lot of editing situations, it becomes last in, last out, right? So because let's say that we all started editing at the same time. So we all got the original record. And so when I hit save, say I hit save first, for that amount of time that I saved, my task name is there. Oleg comes along and he saves the task priority. Well, my task name goes away. His priority is there, right? And then Michael comes along and Michael saves the updated random number. And now Oleg's task priority goes away. And all we get is Michael's, Michael's random number change. And so in that case, we've got a mess. Because there are pieces that, we're in a highly distributed environment. We've got people that are doing things. And so what do people typically do? Well, what they typically do is they say, hey, we're going to lock this, right? So when Jason goes to edit, he locks it. So he's got a lock on this. He goes in, he makes the task name change, boom. Ole is sitting there hitting over and over and over again, edit, 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 right? And finally he gets in, and he gets, because the lock is removed, he gets the form and he makes his change, right? And Michael's just been over there, slamming on the edit button also, so that he can get his right. This is a pessimistic, this is what's known as pessimistic change handling, right? Because we're pessimistic. As soon as somebody opens something, then we're locking the record, and so it's pessimistic, right? We don't want anything else to happen. The other side of the coin is opportunistic editing. And in opportunistic editing, what we would do, and the reason that I brought this up is because the model is decoupled from the selected edit. We can actually say, hey, we're going to create deltas. So what I do is I compare my record to the selected record, and I only pass in the changes that I've made. So my changes would just be the name, right? Oops. Oh no, I wiped it out. Dang it. I should have done this someplace else, right? But my changes would be just the name. Ole's changes would be just the task priority, and Michael's would be just the random number. And in this case, because we're using an optimistic strategy, then my change goes through, then Ole's goes through, and then Michael's goes through, and they all go through. I am pessimistic when I see reactive forms. Yeah, I don't blame you, man. But it's an interesting thing to think about, because when you implement deltas and change detection, you're in a much more difficult area. Because the other thing that can happen, right? I explained like the best case scenario, but what if I came in and I changed the task name and the random number? Oleg came in and he changes the random number and the priority, right? And Michael comes in and he changes the description and the random number. Well, now we've got 3 people changing random number, and then other stuff that doesn't change. What do? And that's where the trade-off comes in an optimistic system. It might be last in, last out, and Michael just wins, right? It may be that we go and we present a change delta to the person. So when I save and I change this and this, then my save goes through because there's no conflicting save changes, right? When Oleg comes through and he saves this and this, well, his version is different than the current version. So he recognizes that, hey, this has been changed, and this has been changed since I last checked it out. But this has also been changed by somebody else. So then we can present him, hey, this changed from whatever to whatever. This is your change. This is the other change. Which one do we accept? And similar, right? Where you're presenting people with, what do you accept? Much more difficult to implement. It's a much more user-friendly model, right? Especially in a highly, in a highly multi-user environment with very, very small changes going on regularly. It's a much better model to implement. But the trade-off is it's a lot more engineering to take care of. There's a lot more to think about. You have to start implementing model versions and things like that so that you can see, okay, based on this version of the model, this is what I thought it had, this is what it has. And there's a lot more engineering that takes place in that optimistic model. And that's why, you don't recommend it by default. Usually what you do is you implement the last in, last out strategy, right? That's the default strategy where whoever whoever hits the save button last is the one that wins. And then you start getting bugs to the effect of, hey, your system sucks, I'm losing changes. You go in and you start investigating. You're like, okay, we need to do some engineering. Let's do some pessimistic locking is usually the way it goes, right? Because that's the next easiest step. And then people are like, oh, you're wasting so much time. I sit there waiting for a record to unlock. And, maybe you waste some engineering time letting them know, maybe that edit button enables or disables so that they're not just hitting edit, 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 and getting back, hey, the record's locked, the record's locked, the record's locked. The button just updates every so often. And so that they know when they can edit. The problem with pessimistic locking, as soon as you hit edit, you've got to lock that record. There are other issues with it, right? Like if the unlock doesn't happen, then you can run into cases where you've got stale locks, keeping records locked that shouldn't be locked. You could run into situations where in the time it takes for you to acquire the lock, somebody else hits edit, so you've got two people still editing, right, in a pessimistic system, thinking that they're going to edit, and then you're in a last in, last out situation again, where whoever hits save last wins. And it just, like, pessimistic locking has some problems with it. Opportunistic is obviously the best, but it's also the most expensive to create, the most expensive to maintain. And, you probably don't need it in most systems. But yeah, it's an interesting discussion to have, and being able to discuss this and the trade-offs when you're in the when you're in job interviews or even at your current job, is what's going to separate you from typical programmers. Most typical programmers will look at this and they'll be like, oh, the model's different than the selected. Okay, we'll pass in the model, which is what we're going to do, right? We're going to do last in, last out. We aren't going to do deltas. Well, we could do a last in, last out version of deltas if we wanted to. Maybe that's what we do. We'll do that. We'll show how to build up the deltas. And do we want to do that? I don't know. Do you guys want to see that? Like, how would you build up deltas and things like that? Or would you, you guys let me know. Because from here, once we get the save button implemented, and the save button is going to be much easier to implement than I thought, because of the way everything's isolated, it'll be very easy to implement. Yeah, you guys let me know. If you want to see I'm pessimistic when I see React. I'm more of a United Airlines guy. Oh man, don't get me started. For those of you guys who don't know, I was in North Carolina last week, visiting one of the corporate offices for the company where I work. I flew Southwest, and Southwest is not a bad airline. It's just all of the flights had layovers. And so I could have flown out Thursday night, but that would have put me into the airport at around maybe 1 or 2 a.m. And I didn't want to make my wife drive to the airport at that time. So I took an early morning flight from North Carolina, which left North Carolina at 5:45 a.m. And due to airport stuff and not knowing it, I wanted to be there early, so my body just didn't let me sleep. I got up at 3 a.m. East Coast time, which for me is 1 a.m., which basically meant that I should have just not slept. So my sleep is all messed up. But yeah, got back. So you want to see, okay, you want to see deltas. Let's figure out how to do some deltas here. So let's first build up the delta, and then we'll update with the delta. Yeah. So let's think about it, right? The first thing we know is that we need to save the model. So in our store, right now we've got two methods, one to select and one to deselect. We need a save to do, and we're going to pass in a to do. We have to, and we're going to do something with that, right? We aren't going to patch our state immediately. Hey, yo, alternate, welcome to the stream. Because what we want to do is, I don't have a server set up here. I was going to show, we could open up two windows and show the, the edits taking place. But instead, what we'll do is we'll create we'll create our delta. So what we need to do down here is we need a function. So this will be function create delta, and this will take in current to do, which is a to do model. And it will take in new to do, which is a to do model, and it will return a delta, which will be a partial of to do model. So now we've got our partial. I'm really curious. I want to see what the AI does here. Very, very curious. Oh, this is hideous. You guys see what it's doing? So, oof. This is really, really hideous. I keep IP banning this guy. You must know John YouTube. We blow. Man, you gotta stop. You gotta stop banning your alternate, man. Just because he didn't invite you out to the lake party and I got invited to the lake party doesn't mean you need to retaliate. What we want to do is figure out what actually changed. This is a horrible algorithm to do that. It's an easy one to understand, right? But it's only checking name, description, done, and then that's it. That's hilarious. We want to do this a little bit different. And we can do this a couple of different ways. I think probably the best way to do it is to use a reducer. So what we can say is we can say reducer or reduce, and boom. Oh, we've got to go about this the other way. So what we want to do is we want to do new to do. Can I do a dot reduce on this? No. So we can do key values here. So new to do dot. No, I want object dot. So we could grab it from the entries, right? Which is going to give us the key on the object. So object.entries is the key value pair. Object.fromEntries gives us an iterable that gives us the key and the value. So we can do object.fromEntries and we can say, hey, new to do. And now we need to reduce it, right? We can say entries. So array.reduce. Oh, no, that's not what I want. Wait, from entries. Oh, this takes a key value pair. This takes key value pairs into objects. So we're going to use object.entries. And object.entries is going to give us some key value pairs. And then we can say dot reduce here. Because we're going to reduce this down to an object. And we don't want this. And so reduce takes in a couple of things. The first thing it takes in is an accumulator. And then we can take the key and the value and the key and the value, and we can destructure those. And then the last thing we want to pass in is this as partial to do model. And that should work. And it's going to tell us that we've got an empty object, right? No overload matches this call. Oh. I think we may need parentheses here. Nope. So that's our accumulator. It's a partial. String, or number, or blah, void. Oh, we're returning a void. That's the problem. We need to return the accumulator here. That'll work, actually. So what we've done, and we don't even need the delta anymore, but let's console.log it just to make sure, right? Console.log delta, boom. And so up here in save to do, now what we can do is we can say, hey, const delta equals, and from here we can say our delta is going to be create delta, and we're going to pass in our, so the first one is the current, so state dot selected to do, and I believe that's a signal. So we're going to pass that in, and then the next one is our to do. Boom. And again, we can console.log. We can say save to do delta. And again, we can log our delta here. And finally, what we can do is we can say, hey, patch state. And the next thing we can do is we're going to patch state, and we're going to say state, comma, and what we can do is we want to modify the selected to do. And we can actually give it, so we can say selected to do, and then we can give it the delta. That should be enough. Can I use a partial here? But we can use a function here that returns a partial. That should be good, right? Can I say, doesn't patch state allow us to patch in a partial? Well, so patch state, if we take a look, and what I should do is, where is my signal store? Angular material, Angular primitives, NGRX toolkit. Here we go, signal store. So reading state, defining store, reactive store methods, putting it all together. Maybe it's here. Oh, that's using patch state, but you should be able to do side effects. Watch states. There's a way to only provide like a partial, and it will use that partial. I guess we're using a partial here. It won't do a deep state partial. That's the problem. I think you're right, Johanderson. Um, I think you're right. I could, and I am providing a partial here. So we're patching the state. But what we want to do here is we can provide a function. So if we take a look, if we go back and we take a look here, it's the store. So did I call it store or state? I called it state. It's not state here. This should be store. So there's my store. This should also be, whoops. Should also be store. And so here, what we can do is we can pass in state. And then we can use mutative.js. Man. Goodbye. Hey, Marcus, welcome to the stream. Good to have you here. Yeah, why just Delta? I finally got the American joke also. We're a Delta hub. Anyway, so our state here, we have to pass back an object, and we can do it a couple of ways. If we use mutative, what we would do is we would we'd use create. Wait, where is mutative? Right here. Mutative JS mutability. Nope, that's not the one. Repositories. So this one is React. There we go. There we go. This is what we're looking for. So with mutative, and it's been a little while since I've done it, is create. Do I not have mutative installed? That could be the problem. Let's look at package.json. And inside of here, I don't see mutative. Okay. That's an easy fix. Because we're using immutable state, trying to do a mutation this way might cause problems. So let's go and add mutative. Okay. P, and then we'll npm install mutative. So that's going to add our mutative package. And now we can go back, and now we can use a create. So with create, boom, now we can take in our state. And the next thing we want is the draft. And there we go. So now we can treat the draft like it's we can mutate it. So we can say return. Well, actually, we can just say draft dot selected to do equals, and here now we can do another spread, so we can do dot 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 draft dot selected to do, and now we can do the delta. And the reason we're doing it this way is this will create an immutable function. This create function returns an immutable function that will take a state and apply this stuff to it. So now we can patch state with that. And the last thing we want to do is we just want to say, oh, we're going to have to create another with methods. With methods. And the reason we're doing this is because we want to be able to call deselect to do. So we'll grab you and put you inside of here. So there we go. And then the last thing we want to do is just right here, we can say this dot select to do. And that will allow us to do that. And so now we've got a delta, right? We use this function and we used reduce on the entries from new to do. One of the things we could, well, there's another way we could do this. Instead of using reduce, we could have built it up from, we could have built it up by using filter. So we could have filtered out entries and then turned around and used object from entries to build up our, we could compare that actually. So we could say const delta 2 equals, and again, object dot entries new to do. And here, what we can do is we can just do filter. And we'll destructure the key value. Yep. And so then we can say return current to do does not equal value. Great. And that will give us another object, and then we can console.log delta 2. We can just do object dot from entries delta 2. Boom. And we can see the type of delta 2 is not a great type. But let's compare. There are always multiple ways to go about doing things. Let's move mutative down here. And let's refresh this. Boom. So again, we'll go ahead and edit this one. We'll mark it not done. We'll make that. We'll do blah, blah here, and we'll change that. And when we save it, It works if you if you call the method this dot oh, guess what? We so this is a form of so we decided to emit there are a couple ways to do this. One way to do it is we could inject the store immediately. The other way to do it is the other way to do it is to inject the store directly. I typically don't use outputs, but we'll do it anyway. So we'll say edit saved equals output, and we're gonna say to do model. Boom. So here now we just say this dot edit saved, and then this dot model. Oh, I need a dot emit on this. So we're going to emit this event, and then in the to do, we have to bind edit saved equals handle saved, and we need a dollar event here. And this is typically why I don't do it this way. The benefit to doing it this way is that the to-do form can be injected anywhere. What's it not liking here? Oh, must be focusable. Yeah. We're going to clean that up anyway. And so the yeah, you know what? We're going to change this. This is the reason why I typically don't do inputs and outputs, because they grow really, really quickly. And it's a personal choice, right? People will argue both ways, and it's really just a personal choice. We're going to take all of this out. And instead, we're going to say const we're going to do read only. Are we using, so we're using the model here. Well, we'll try it private. So read only to do store equals inject. We're going to inject the to-do list store here. So let's go ahead and bring that in. We're going to bring that in. And so here, our to-do factory is that. So we don't even need that anymore. In the constructor, we're going to use this dot to do store dot selected to do. So we're going to watch that. So that's all we have to do there. It's the same code either way. As soon as that changes, we want the factory to change. And so then the last thing we need to do is right here, instead of emitting this, we can just do this dot to do store deselect to do. And instead of trying to emit all of this stuff, now we can say this dot to do store dot save to do this dot model. And the other thing we can do is we don't even need to call this. The other thing we could do is right here in our with methods, save to do could be not an RX. We want a signal method here. And our signal method is going to take this. Boom. And I think I need one more. Is that right? Oh, I've got my paren in the wrong place. It needs to go here. Oh, and it can't be this. Why was I thinking this? It's store. That wouldn't have worked anyway. Yeah, so there we go. And so now what we can do, because we've got a signal method here, we don't have to read from the model. We can just pass in. The cool thing about a signal method is the input. So save to do could be a signal. It could be, why not a linked signal instead of an effect? That's actually a good call out. Linked signals are actually a really good call out here. Excellent call out. I'm not as good at using linked signals, Tolstoyevsky. What's the famous Tolstoy book? Is that what your name is a reference to? Oh, it's I can't think of it right now. Yeah, you're absolutely right. We could do a linked signal here, and it would be way better than what I've got. So let's make that change after we make sure this all works, right? Thank you for the call out. So here we go. We've got this. Let's go ahead and we'll just make a couple of changes. Right. Save that. We can see delta done false. So we changed the done from true to false. Random number to 222 and task importance. So we can see that both of our methods for building up the delta worked, right? They were the changes that we wanted. We also got our delta here. However, our patch state didn't work. Because we can see that we're still getting this. So that tells me we need to do some more work. I was hoping that I could use some mutations. Mutations won't work. V-Fave Girl, how hard is coding from 1 to 10? Haven't had a chance in stores to use with linked state, but I like it. And that might be another way to go too. So V-Fave Girl, how hard is coding from 1 to 10? That depends on where you're starting from. Are you starting with no knowledge of coding, or like for me personally? Here's the way I look at coding. Coding is learning another language. Is the way I look at it. You're learning to speak to a machine in the language that it understands, but not really. You're kind of learning an intermediary language that can be translated into the language that the machine understands. And so, like when I learned Spanish, there was a whole bunch of ways to think about things differently. I had to think about, adjectives coming after the object instead of in front of it. I had to think about different verb conjugations. I had to think about different phrases. Like if you translated some of the English phrases straight into Spanish, they made no sense. And it's the same thing. No knowledge for coding. No knowledge for coding, you're probably around, I would put you around like a 6 or a 7 difficulty scale. It's definitely not the hardest thing in the world to do. And there are forms of coding that are very, very easy to learn and very, very easy to start with. But it's very much like learning a different language. And then the problem with that is that there are different languages within, like sub-languages, dialects within the language that you're learning. So you're learning how to tell a computer how to do things. But then within telling a computer how to do things, there are different dialects. You've got, JavaScript, you've got C languages, you've got Lisp styling. Like the dialects are different. The concepts remain fairly the same. And as I say that, I laugh at myself because the basic concepts remain the same across dialects, right? There's coding's very, very difficult. And not very, very difficult. It's very, very deep. It's not difficult. Again, 6 or 7. I would put it at a 6 or a 7 for somebody with no knowledge. The level of like if you take me for instance, I've been working in code, oh man, like 40 years. 40 years doing coding, right? And maybe 25 of those professionally. For me to pick up a new dialect is much easier than somebody that's at the beginning of the journey. Hey, that's awesome. You're going to make a 2D game. What languages are you using, and what are you planning to build it in? That's awesome. I highly encourage that. I'm a big fan, and feel free to ask questions here, right? I'm happy to help people out. Yeah. The style of coding we're doing here is very much for the web, but the concepts here will translate all over the places. Yeah, but if you want to push for promotions and keep yourself learning and facing challenges, then you choose to go 6 to 10. Right, and that's the thing. Is that there like any job, there are levels within it, and the depth and the importance and stuff. But the nice thing about coding is it's the great equalizer across just the entire globe. The barrier for entry to coding is very, very low. Really, all you need is a computer and probably the internet in today's day and age. If you've got a computer and the internet, then you can get in, right? And that barrier of entry is higher in third world countries where owning a computer is much more difficult. But there are, public areas where you can go and get access to computers and things like that. And that's what I love about our industry, is that anybody with desire can pick it up. So the fact that you want to build a 2D game, you're going to build it up. Yeah, okay. So English, I think the software is Godot. Okay, so when I say English, or when I said language, and you responded English, that tells me that you are ground floor. So Godot will allow you to use a couple of different, I was calling them dialects, but in general, people call them languages. So Godot, I believe, allows you to use JavaScript or TypeScript. I think it allows you, let me not give you bad advice. Let's instead go take a look at Godot, right? So Godot is an amazing engine, great for building games. A lot of games that people have heard of are in Godot. I know that Brotato recently changed over from Unity to Godot. Brotato is one of my favorite games. Um, so definitely a powerful engine. Let's just take a look at the languages. So C Sharp. So you can use C Sharp if you're a .NET programmer. Pick from a variety of community-supported languages. So Godot is built to be extended. It can use programming languages. Thanks to our community, there are many popular tools like Rust, Nim, Python, JavaScript, and C Sharp, right? So you can pick one of those languages. It is. So I don't stream this very often, and maybe you guys can let me know if you guys ever want to see like building a game in an engine like Godot, if that would be fun. I've built a couple of very simple games, and if you guys are interested, let me know. But yeah, the languages you're going to be picking are C Sharp, or my recommendation to you is if you're going to learn Godot, C Sharp or JavaScript is probably your best choice. C Sharp is going to be a more difficult language to learn, but it's probably, because they're calling it out by itself, it's probably a native language for Godot. And so you can use, if you learn C Sharp, you'll be able to find a lot of tutorials. And you can write desktop mobile platforms. So it looks like C Sharp is probably your best choice. JavaScript, the only reason I would recommend JavaScript at all is that it's a very easy language to learn, and it's a very forgiving language. C Sharp is a much more difficult language to learn. It's not, I wouldn't put it like a 9 or a 10. C Sharp, I would put it like a 6 or a 7. JavaScript, I would put it like a 5 or a 6, 6, 7, right? I just memed and didn't even realize it. That's what happens when you have teenage kids. Now, anytime I say the numbers 6 and 7 together, I have to laugh. Oh, you have Python. Python is a good language. So yeah, if you're gonna go Python, like just find your tutorials in Python for Godot. Python is a good choice if you want to add like LLMs to your game for whatever reason. A lot of LLMs naturally speak, Python has a lot of stuff for interacting with LLMs. So yeah, good choice. Godot's a good engine, powerful engine. It'll write a 2D game for you. And I'm very impressed that you're going to do this on your own. I will tell you, Python is a language I don't know. Like, I know enough Python to be able to modify scripts when I'm working with LLMs. I couldn't write something in Python from the ground up. It would take me some time to learn Python and Python conventions. But I think you're on a good path, and I think you've chosen a strong language in Python, and I think you've chosen a strong engine with Godot. And I think all my friends who code said use Python. Well, all your friends who code said use Python. That means they probably know Python. So do Python, right? If you're going to, I mean, your friends who code will be able to help you with Python if they told you to use Python. So yeah, that, none of the choices you made were bad choices. And I'll be honest, if you're learning to code, there's really not bad choices that you can make. Because you're going to need to learn the fundamentals. Once you have the fundamentals, then you can start worrying about bigger decisions. But for right now, you're on a good path. Highly support what you're doing. All right. Hey, thank you for subscribing. I appreciate that. Or following, not subscribing. Thank you for following. I really appreciate that. It means a lot. Anyway, let's get back into what we're working on now, right? My save isn't working. And the reason my save isn't working is because I did it to myself. What I did to myself is I created this immutable state. So I've got two immutable states. And then I tried to mutate the object, and that was dumb. What I should have done is inside of here, we need to find the index of the selected to do. So we need to go and say, we can say const index equals, and here we're going to say, I don't know why it's trying to say index has a value. I guess it's because it's putting this into that. But our index is going to be state dot to do's dot index of, and we're going to say we want to find to do, and we want to say to do dot ID. Boom. Right. Can I not do that? I think I need to use find instead of index of, right? Find index. That's what I want. So now we've got an index that's a number. So now what we can say is, instead of doing draft.selected to do, we can say draft.todos index equals, and we're going to want to spread this one. So we're going to say draft.todos index yeah, that works. And the nice thing about using something like mutative is we can use what looks like language that's going to cause a mutation, but mutative actually uses proxies underneath. And so it's not, we're not actually doing a mutation here. And that's why I like mutative, is it allows me to write code in an immutable way that looks like I'm mutating the object. VFave Girl says, when I know enough coding, I'm going to try to make the game in 3D instead. Man, that's awesome. Translation from a 2D space to a 3D space requires not a lot changes, I'll be honest. But then a lot changes, right? One of the big things, so the coding side of 2D versus 3D isn't that different. So when you're doing coding in a 2D space, most modern engines, what they do is they're actually treating it like a 3D space with a locked camera. So the camera will never change on, like, you know, if we consider like, you know, this is your 2D game backdrop, right? And then you've got your classical X and Y coordinates that you'll think in. But you've also got the Z coordinate here. And what happens is that your camera is at a fixed spot on the Z coordinate. So most modern engines treat 2D games like they're 3D. They use 2D sprites, and 2D sprites are the assets, right? Like the characters or the enemies or things like that, the background images and things like that. So you'll use 2D sprites. So that's one difference, right? So you go from using 3D modeling to 2D sprites, which is a lot easier. It's also a lot easier to do like pixel type games and things like that, which is one of my favorite art styles. But really, the camera's just locked above a 2D plane, and then your game takes place within the view of the camera in that 2D plane. And so a lot of thinking in games, right? Like if you consider something like Super Mario that has pipes and background images, and things like that, and pits and things, right? What you're really seeing is, as you move, what's actually happening is, you're moving along this often large area, and so as you move, right, your camera is fixed to the character itself, and so the camera is always fixed to the character, and so as you move, the camera is scrolling along the larger area, and there are ways to optimize loading and unloading, so you can optimize memory for like mobile devices and things like that, right? But the reason I say this is that the difference between a 2D game and a 3D game is not your coding skills. The difference between a 2D game and a 3D game comes down to the methods you use. So in a 2D game, you'll use 2D, like most of the methods you'll use will be like 2D. They'll have a 2D in them. Your physics engine will be two-dimensional. And then you'll use sprites instead of 3D models. When you move into a 3D game, now the camera is free to move and rotate. So there's a little bit that you need to do there, but the game engine is going to handle most of that for you. So you'll start using, instead of method 2D, you'll start using method 3D, and be passing in the X, Y, and Z coordinates. But that's what changes. I guess the reason that it's good to learn on a 2D game versus a 3D game is not coding complexity. The reason it's easier to learn 2D versus 3D is it's easier to reason in X and Y, because we do that most of the time. Yeah, so I don't fuck. Yeah, you should definitely use a different project for the 3D game. But it's good to learn in 2D because then you only have to think about two directions, right? In 3D, now you're starting to have to worry about three directions and camera rotation and stuff like that. So it's not the coding that's more difficult, it's the way you approach the problems that becomes more difficult. It's so in programming, there are two terms you'll run into a lot. There's coding, or the practice of writing the code, and there's another term that you're going to start running into a lot, and that's the architecture. The architecture is the way you think about how the code is structured, the way you approach the problems in your code, and things like that. And the architecture in a 3D environment becomes much more complicated than the architecture in a 2D environment, because adding that third dimension doesn't just add 33% more complexity. It actually increases it maybe by a factor of 10. I don't know what it actually is, but there's a lot more to think about there. So even for experienced coders, jumping straight into a 3D game for your very first game is probably not a good idea. Learning 2D games allows you to learn game concepts like game loops, hit collision detection, all sorts of stuff in 2D space, so you don't have to worry about the 3D space, right? It allows you to focus on concepts and learn those concepts that then can be applied to a three-dimensional game. But yeah, you're making good choices here. So anyway, coming back to what we were doing, I'm going to get rid of the second delta. It's just wasting. We'll comment it, right? We'll just say, hey, this is an example of not using reduce, right? So there we go. We'll leave this commented. It's just showing that there are multiple ways to solve this problem of building deltas. And the different ways do different things. This way, we're mutating the ACC object as we go through. No, man, we're actually creating a new object, right? Because our spread here. But the filter, I actually find this one easier to read than the reduce. Because we're just filtering out properties, and then we wind up with the properties that we want. The problem here with the filter is, like, if we want to, say we want to return object.from entries, and we're going to use delta 2. Oh, never mind. It's perfectly fine with that. Well, in that case, let's take out example of using reduce. So there we go. And this is an example without reduce. I actually find, like, reduce can be difficult to read sometimes. And there's another interesting issue to the reduce here, that makes filter superior. So with the reduce method, in the worst case scenario, let's say that every key, like, we changed everything, and let's say we've got like 1,000 keys, right? This spread operator here is going to iterate through every one. So this reduce could potentially become an ON squared operation. Whereas the filter is always an ON operation because we're filtering it out. Well, and then we're iterating, right? We're iterating again. So really it could be, really this could be an O of 2n in worst case, right? Worst case is O of 2n. Here, worst case could potentially be ON squared because we're iterating through the loop every time through, right? Not technically, no. But towards the end, we are iterating through effectively the entire loop, right? Once we're at 900 items in ACC, and we could probably use append or something like that to get the same performance. But the way I wrote it, this loop is ON squared, versus this loop, which is really 2 iterations in the worst case, right? So we've got 2,000 iterations here versus 1,000,000 potentially. Well, it wouldn't be 1,000,000 because we're right. the way it's written, this one is much better than this one. We could optimize this one to make it better, but I also find this one easier to read. So it is what it is, right? A good thing I start with 2D with art is a good choice to learn before learning to model in 3D and code it. That's where modeling and textures and lighting and particles and things like 3D becomes much more complicated, not in the code that you write. The game code is going to feel very, very similar to you. In 3D gaming, you're going to have like particles, particle emitters that you might attach to somebody. You'll also have like shaders. So like in a 3D game, say you have a weather cycle, and you want to make the ground and your character look wet. Well, now you need to write a shader that can make the ground appear wet and have puddles. But you also want a shader that makes your character appear wet and maybe, water drips from the hair or the clothing, and then you've also got like, cloth physics and all sorts of stuff to worry about, where that's where the complication really comes in. And then in the modeling, even modeling out the skeleton to allow your character to move in 3D, that's a lot of work. And then doing the rigging and things like that. And there are tools to help you do that. But that's a whole bunch of stuff to learn that has nothing to do with the actual coding. And so, you can go and get assets, and typically there will be free assets or things like that. But it really depends on how much you want to learn yourself. But 3D modeling is something I'm terrible at. And, if you're going to do a 3D game, back when they first started doing 3D modeling, low pixel or low poly, Final Fantasy VII is not something that, modern gamers would be very accepting of unless you're able to hit that like nostalgia and make the low poly characters. Even then, you're going to have to rig your characters better than they did back then, because people are still going to, even in a low poly 3D environment, people are going to expect more emotion and more movement from your characters, and things like that. So yeah, you like to do your own things in your own way, and that's the best way to go about it, honestly. So anyway, we're gonna use this one. I honestly thought that object from entries, but TypeScript has gotten better at being able to recognize that my entries come from a to-do model. So my entries here in this array are going to create a partial of that. 3D modeling is art, and I can do art well. You're way ahead of me. Artists will always do well in the gaming industry, especially artists that can understand the code. You'll do very well. So I'm very impressed by that skill. Anyway, let's see if I manage to fix things properly. So we'll go ahead and go here. We'll refresh. We'll try to change this one again. So we'll change this. We'll change our rating to a 2, and we'll save that. So we've only got 2 edits here. So we'll see. Very interesting. Well, we can see that that worked. There is one problem with our code. And that problem is that, well, we can create the problem so that we can see it. Let's go ahead and edit this one, and let's set the ID to 2. Boom. So we can see that I set the ID to 2, and now we've got a collision on the ID. So now if I go edit this and I save it, notice this one stayed the same, but this one changed. And if we look, like the deltas that it built up, it only recognized that random number changed, so it only changed random number because that's all I changed. But now there's no way to change this one until we get rid of this ID collision. And so that's a big problem we've got. And we need to figure that out. I think the best way to go about doing that is just right here. What we can do is we can say, hey, if key equals ID, and we're just going to return false because we always want to filter out key. And the other thing we can do to just make this more explicit is we can say, hey, const, you know, let's get this on the to-do model. So in the to-do model, what we can do is we can say, hey, we just want to we want to make non-editable keys, so we can export type, or we can export const non-editable keys equals, and here we're going to say ID as const. And so now the other thing we can do is we can even say, hey, non-editable keys is we can create a type that we can use for this. We can say type non-editable keys equals, and here we can say array, or we can say key of to-do model, and we can see here that we've got our keys. And so we can say non-editable keys here is non-editable keys array. And so now this works because now we can see that, and we do need the as const here, I believe, otherwise this breaks. No, it doesn't. I like the as const because it narrows the type. So this type is narrowed to just an array that has the ID string in it. And then our non-editable keys can have any of those, but it has just the ID in it. So then we can come back to our store and we can say, hey, we can say if, and here we can say non-editable keys dot includes key, and we return false. Oh, it doesn't like this. Because it's saying key is a string, which is true. So entries comes in as a string. So we're going to have to do as non-editable keys, which means we have to export it from here. And these are some like TypeScript tricks that you can do instead of having to um, go with like any or something like that, right? We can keep our we can keep our type narrow. And what we've done is we've said we've given good values that allow us to filter out the ID. So now we've got if the key is in there, great. I mean, the other way we could go is we could have gone with like a map or something. We aren't going to have a lot of these, so I think it's fine. But with a map, this would be an O of 1 lookup, whereas this is an O of n lookup. Really, it's just to compare. Right now, where there's only one item, worst case scenario, it's a compare. Actually, it's a compare every time. I was playing with a code to make a small chat box, and now I finally found out a way to make a new tab to say hi. And that's cool. In your browser, you're saying that you were playing with that. That's really cool. Like that's the thing I love about coding. VFave girl, is the best thing about coding are those dopamine hits when you figure something new out. And that's what I love about what you're doing. You're going in to learn it yourself. Oh wait, no, you're talking about in Godot. You created a tab to say hi, right? Like you made a significant step, and that significant step, like those dopamine hits just keep you going. Playing with Python, exactly. Like it's just those dopamine hits, right? You're like, nothing works. And suddenly you've got a tab that says hello. And you're like, hell yes, I figured it out. And pretty soon you'll be able to create that tab and make it do something else and then something else. And that's the cool thing about learning to code, is it's all incremental. Making those small successful steps, you're on a good path. You're doing some amazing stuff. And like those days of learning, there's a lot of frustration, I totally admit. There will be days where the frustration will be like, why the hell am I doing this? But there will be other days like, hell yeah, I'm invincible. I own the world, right? Like, it's such a good feeling where you are, and I love it. And the cool thing about coding is that never goes away. There's always something to learn that makes you feel like, why am I even doing this? And then, within a little bit of time, you make that small victory and you're like, yes. And then the next small victory and the next small victory. And pretty soon you're doing things that you're like, how did I even get here? This is awesome. So yeah, it's one of the best things about our industry, is that there's always that opportunity to learn something new. There's always that opportunity to be on that roller coaster of, I totally suck, to, this is amazing. And you'll even see that on my streams. There's a lot of times where I'm like, man, what am I even doing? And then, we figure it out. So let's go here. And let's change this again. We're going to make this a 1. We're going to change this, and we're going to change this to a 5. So we should see that we set this to false. We change the ID, we change the random number, and we change the priority. So yep, done is false, random number, and task importance was changed. So that's good. NGRX signals, the function returned by signal method was called outside the injection context with a signal. This may lead to a memory leak. Make sure to call it within the injection context. in a constructor or field initializer or pass an injector explicitly. This is an interesting call out. And what it's saying is inside of this form, me changing this call to use a signal actually introduces a potential memory leak. And the reason it introduces a memory leak, this is actually a bad thing for me to do. Because basically what I did is I tied the model. So anytime the model changes, it was going to update. That was breaking things. This is the right way to do it. I'm not going to change away from, well, we can change away from this. It doesn't matter at this point. We aren't going to watch the signal. And because we aren't going to watch the signal, then it doesn't matter that this is a signal method. But what was happening when this was a signal is we were basically telling it, hey, watch the signal that we created in this model. Well, this model is going away every time, but we're still watching that signal. So when the garbage collection comes along and it says, hey, can I get rid of model? It says, no, I've got something watching model, right? And so the way we could fix this up is we could pass in an injection context. And in that case, the injection context would tell us, when the on destroy was happening, we could use, the on destroy with that injection context and remove that basic, we could call it a subscription, but it's the watch on the model. It was a lot of extra ceremony for no real benefit. We only really want to save the to-do when we get into this method. We don't want to set up something that watches that, because that could potentially lead to us mutating the store when we don't want to. And one of the key things that we want is when I come here, I can still go and be like, hey, cancel this, and it stays the same, right? That probably wasn't a good example, but if we cancel that, we can see that it's still done. And when we go to edit it, but now if I make this a 2, and we change this and we change this and we save, we can see that my ID stays as a 3. And this might be a bad user experience. So one thing we could do is we could come into our model and down here, we can take form.id out. And what we could do is we could say, well, for right now, what we'll just do disabled form.id. And that should just disable it, I believe. So now when we come in and edit, yeah, our form is always disabled. So now we can't change it. So we take out that bad user experience. Because if we don't do that, then we get a bad user experience, because somebody might go in and change that form ID to be something, right? And we have a problem. When we get into the case where we're creating a new item, is that going? Yeah, it's going to set that. In that case where we create a new item, we're going to want the ID. Well, we may not want it editable there either. We may just want to pick like the highest ID and use that. We'll see what we do. But yeah, we're in a better place. We've created a better user experience because now they can't edit a field that we don't want them to edit. It's just there purely for display. And because it's for display, we also removed it from we removed it from the deltas that are built, so it's never going to be saved, no matter if it changes or not. Yeah, we're in a much better place. So let's go ahead and commit this. It's at the end of the stream, but I do want to change this over to a linked signal because this is a bit of a weakness, right? I built an effect here. In this form, I built an effect. That effect is not necessarily the right thing to do. We could do a linked signal on our selected to do. Can we do that with the model? Do you guys know? Like, that's an interesting one to think about. Actually, we could. It doesn't have to be a signal here. This could be a linked signal to the to-do store selected to do. Yeah, we don't need this effect. This can be a linked signal. Let's go ahead and bring that in. And we're going to link this to this dot to do store dot selected to do, which means now we can take out this entire effect. And so now our model is linked entirely to the selected to do. So now, if we come back here, and let's make this go away. So if I select this, we're on a 3. If I select this, we're on 2. I select this, we're on 0. Man. There we go. So much better. So much better than where we were. And we can still, talk about Godot, right? And, say thank you, the fave girl, for the follow. Boom, we save that. And there we go, right? So we are getting the edits in place. We're in a much better place. And this is such a I need to get better about thinking about linked signals. Like, if we go take a look at if we go take a look at our to-do form here, right? So we took out effect, we took out model, that's fine, but we replaced it with linked signal. We've got inject, but we took out our output. We took out all of this stuff, right? Because we don't need it, because we're just injecting it straight away. And then if we look at our code here, this is our button stuff that cleans up our buttons. But look at this. Our constructor has this nasty effect, which means we're watching selected to do. It also means that as written right now, this can only work in something that's projected to the browser. So if this code was ever going to be run on the server, we'd have to write it, we'd have to surround it in an on next render, inject the injector, and it would just be a mess. Instead, we just linked it using a signal, and we took out all of this code, and we simplified a whole bunch because now we're not emitting stuff. And the reality is this form is going to be tied to this list anyway. And this is a weakness in my modern Angular code, because one of the things in my current job, I spend a lot more time doing architecture type stuff. So like the amount of code I write has gone down dramatically. So I don't have this instinct that linked signal is better than this. So who was it that gave me that question? It was Tolstoyevsky, right? Thank you. Thank you for calling that out. Please feel free to ask questions like that. It was non-confrontational. He was suggesting a superior way to do it. It's obviously superior. One line, we modified one line of code and took out a whole bunch of mess, and we're in a better place. We're also building deltas, right? So the other thing we did was we removed the prop drilling. This is going to lead to prop drilling. If we keep building our forms this way with inputs and outputs, we're going to be drilling props through, and I'm not a big fan. I'd much rather pass injectors and set up proper injectors, kind of the same way we did with the what did we call it? Angular dynos? Was that what we called it when we built that form using injectors that we passed to the edit and the add form? That's my preferred way of doing this. There's more thought that goes into it, and it's not obvious. That is one of the downsides to this, is that it's got a hidden dependency that you may not be aware of. That's a big downside to going from inputs and outputs to what we're doing, where we provide the store and then we just inject the store because we expect it to be there. So there is a big downside to this. I do want to call that out. But the upside is we don't drill props through things that we don't need them, and we don't. We aren't adding handlers at a higher level. We just aren't having to do that. We took advantage of TypeScript to keep our stuff strongly typed. We disabled the ID, and then in our store we use the deltas, and we used a couple of different ways of building deltas to show you. There are different ways to do it, and thinking about things in different ways is a big help. But yeah, we're in a good place. I went from thinking linked signal was so dumb and useless when they added it in V19 to thinking they were the best by 19.1. And I agree with you, Michael. Like when they first came out with linked signal, I was like, well, can't you just do that with a computed? That doesn't make sense. And luckily, people were friendly with me and, kind of approached me like, oh, yeah, Jason, you don't understand it. Luckily, that's the way I was treated. And eventually I learned linked signals are powerful. I mean, just the use case here. This is incredibly powerful, that we don't have to do this stupid effect that I built. I feel silly, but that means I've grown. That means I've learned, right? If you can't look at your old code and go, man, oh, Jason, I'm so glad you learned. You're not getting better, and we need to get better. So today I got better. Within, within a week, I'm like, oh, why did you do this? Yeah, this makes sense. And even last week, right, the model's set, like me trying to manipulate the form. By the time I was done with that, I was like, man, these people are gonna think I'm the dumbest person ever. But I like to show that even as you get experienced, you're going to struggle. There's always something to learn. And that's the power of just what we're doing, right? So, can you explain more about delta? Couldn't it cause conflicts if we change the same value? Or it will store that latest one. Exactly, Ole. Yeah, let's talk about delta before we stop here, right? And you know what? Let's not do it here. Let's go and let's pull up an Excalidraw. Where is my Excalidraw? Extensions. I know I have one. Here it is, right here. All right, let's get a new one, right? Reset the canvas. Maybe? Yes, clear the canvas. Okay. So let's say we've got this object, right? And within this object, we've got green, blue, and orange input, right? Or properties, right? We've got the green, the blue, and the orange property. And then let's say, and maybe we'll represent change sets with circles, right? Let's say we've got this change set. Well, if we put this entire change set inside of here, right? Control C, Control V, and we'll make it smaller. Boom. And then we've got another person making a change set. Right. In this case, we talked about this, right? When we go to save back to here, and when you go save back to here, we've got a conflict, right? And the term for the way this mostly resolves itself is last in, last out, right? LILO, last in, last out. So whichever person here hits the save button last is the one that wins, right? And in the case, if we go in and we, you're a 1 and you're a 2 and then you're a 3, right? And then I won't go through and fill everything out, but let's say here we change, this one changes this one to like a 5, boom, and this one changes this one to a 7, and then the other ones are the same, right? When this goes back and we save, let's say this one saves first, for a while this will be 153, but then it changes to 127. This is the last in, last out, right? You can do anything at a computer if you have some private one-off helpers, but in many cases it is just more intuitive if you have one-off overrides or need two-way binding. Exactly, Michael. And so Michael wins for sure. Anyway, so we've got this case, right? So what do we typically do in this case is we do the pessimistic locking that we talked about before, where if this person checks it out first, then they lock it. This person can't do the edits. And then eventually when they can do the edits, this will be 153. They change it and then it will be 157, right? In a highly, collaborative multi-user environment, this is not a good way to do it. So what we typically will do is we'll change to deltas. So when we change to deltas, we do exactly what we're doing with our code, right? Where so in our code, we changed it so that we have this circumstance where we've got a 1, we've got a 5 and a 7. So in this case with deltas, then we only apply the deltas. So when this person saves, they only save here. So it becomes 157. It doesn't matter if they do it before or after. If red does it before or after purple, it really doesn't matter. Because the delta changes just the blue or changes just the orange. Well, to what you're saying, Ole, is what if both people also change green, right? So what if our changes here include a green 3, right? And then maybe here we do a green 9, right? Well, great. In this case, when this person saves, it becomes 353. Okay, we're good. However, we're again in a last in, last out situation. When this person saves, it becomes 957 because they saved last. What happens if the 3 is actually the most important change, right? And the only reason this person changed to 9 is because they saw a 1 and they didn't know what the 1 meant. So they went and asked somebody and they said to put in a 9, but had they seen a 3, they wouldn't have touched it, right? What happens? Well, in a last in, last out situation, maybe it's not bad, right? Maybe it's not bad that this winds up being 957. We still get the 5, we still get the 7, but this field under contention is the last in, last out field. And that, right, we've minimized the contention because in the original example, we were resetting the entire field, right? In the case of the 5, it was 153, and then when the 7 saved, it was 127. Obviously, much worse than we've got here with the 153, right? 353, and then 957, right? Much worse than the case because we are getting important changes, but the conflicting changes are being overwritten in a last in, last out. It's so we're in a better state by just implementing deltas. Right. So what happens, right? Because this typically becomes an issue in multiple users. Like imagine we had 10 users trying to edit a shared view, right? This is where Zod can't help this is where we add, a V1 here, and let's put it at the bottom, right? So this becomes V1. When this person checks, they know they had V1. When this person checks, they also know they had V1, right? They both checked out V1. So when this person saves, this becomes V2, right? So in this case, we've now got a tracking field. So every time this field anytime this field is checked out, we know what version we've got. We're passing that version back as part of our delta all the time. And so this person's V1 versus V1, great, it goes through. So now we're at, we've got both 3, delete that. And this one becomes 5. We can go ahead and delete that. And this one becomes 3. And we'll delete this one. Right? So in the V3, we're at 353. Well, along comes this one and says, hey, my deltas are against V1. And it says, oh, I'm at V2, so I need to check the delta. Well, in V1, right, if we copy this over, and we just put it here to remind ourselves, V1 was 1, and here it was 2, 3, right? So when we compare against V1, we can see, oh, or orange or brown or whatever color you want to say hasn't changed. I can allow this to go through, right? So this can become 7, but wait, 1 changed from V1, green changed from V1 to V2. In this case, if we do last in, last out, right, then it becomes 957. If we don't do last in, last out, what we would need to do is we would need to say here, we would need to be like, uh-oh, right? I need you to look at something. And in this case, we would have, we would say, boom, right? Actually, that's the wrong one. It's this one, right? We would give you some way of knowing that it was originally a 1. Currently, it's a 3. And you're proposing a 9. Right? There would be some way to communicate this to you, right? And it might be something like, it might be something like that, and maybe we go with that, and maybe we go with that, right? So we can see you would need to say, okay, I either pick 9 or I pick 3, right? And that would be your new change set against V2, right? So, or against V3, because we could say, hey, the 7 goes in, right? This then becomes V3. This comes back against V3. Right, so here we would say this is against V3. And we can top align, we'll bottom, I don't know where we're going to put that. I don't know, right? I guess we could, there we go, right? For whatever reason. So now your change that comes in from here will be V3 to V3. And so you're either picking 3 or 9 for the green field. And then based on what you pick, then it would update this. There's a lot more engineering involved in creating this path right here. This is the expensive piece, is creating the diff, because in this case, we've only got one small diff, right? And often the way these are presented is, you know, something like this. It was this, it currently is this, you're proposing this. And you could have multiples, right? You could have the same for blue and orange. And so it's building these diff viewers, building the way to communicate back, building in the version tracking, and all of that leads to more engineering. But in a lot of cases, we can just ignore this piece and still stay with the last in, last out. Because in most cases, all you're getting are the deltas anyway. And it's unlikely that we'll go back to old stale data. You might get data that differs, and the last person to save may cause an issue. But if we look at it, in this case, it's either a 3 or a 9, right? And so one field is off versus the entire field resetting and becoming an issue. And so does that help with the idea of deltas, Ole? I'm going to assume it does. I do need to end. Okay, and this is a powerful concept. This is a very powerful concept. I once built so at an auto auction, we had what were called condition report writers. And with the help of some other people that I worked for at the auto auction, we built this application, and the application would send deltas. So they would check out the condition of the car, they would add or change values on it. But we had the application ran in a green screen. It ran on a Windows mobile ruggedized tablet. It ran in a web browser. It ran in, it ran in dealers' mobile views. And so we could have like 10 or 15 people looking at the same vehicle. And the dealer might be saying, yeah, fix these things because they'll get a higher price. Somebody else might be saying, oh, we looked up the VIN and it's got frame damage and blah, 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 right? So they might be editing that. And the condition report writer might be out there adding times and things to the damage on the vehicle. So you could have people editing all sorts of parts of the vehicle, but we had to write a green screen change modification, right? We had to write one for a Windows application. We had to write one for a web browser, and we had to write one for mobile. And so, this piece is significant engineering, but in that case, it allowed us to, and the mobile changes, we limited what dealers could override, right? Like dealers might go in and change something, but we're like, no, the office said it. The office is right. The dealer's not going to change that, right? So a lot more engineering involved here, but it's very, very good for highly collaborative environments. For multi-user environments, this is often good enough. Last in, last out with change deltas is often way better than pessimistic file locking or losing changes. We're getting closer to, this is, like the old, like if you look at pessimistic file locking, if you ever did the old SVN change detection, it was horrible. But it was still better than CVS, which was probably one of the worst, but that was still better than renaming files on the web server, right? So we incrementally got better until we're at like get, right? And it does all of the stuff we discussed here, but you can do this for your data also. This is very much like architectural level discussions that you should be having. You should be aware of the trade-offs and the benefits that we get. And, pessimistic file locking is often good enough. This is probably better than pessimistic file locking in, I would say, like 80 to 90% of the cases. And this is like the gold standard of change handling, but it requires you to build so much more. But yeah, thank you everybody for showing up. Thank you guys for all of the participation. I had a lot of fun discussing it. As always, I encourage you guys to ask questions. I had mentioned that I might not stream next Sunday. I think I'm going to stream. Thanksgiving is Thursday here. I think I'm just going to stream. I want to get the data grid in place so that our application doesn't look so stupid. Like our application as it looks right now, it's not really a to-do list, right? We could do a lot to make this better. So we'll do that. And then we need the ability to add new to-dos, but I'm going to wait to do that until after we've got the TAN stack table in place. And then the last thing I want to do is add a date that we can set and allow it to modify the look of the table based on if the date has passed or not, and based on if we're done. That's where I would consider this application done. And then we're coming up on the holidays and Christmas time and the New Year. So I'm not sure what my streaming will look like. Last year around Christmas time, we played some games on stream. Maybe we'll do that. I really don't know what streaming is going to look like. It might be last minute, me being like, hey, let's stream. There might be some extra streams. Who knows? But yeah, thank you all. Thank you, VFave Girl, for showing up and sharing your journey. I look forward to seeing you guys all next Sunday at 10 a.m. Mountain Time.